Perfect. Okay, how's that? Everybody can see? Audio's okay? For the benefit of the Longhorns fans in the audience, closest I had to burnt orange. And to the Brazil fans in the audience, nah, nah. So hi, I'm Greg Wilson. I run a yeah, I'm not making it home tonight with both my knees, am I? So, my name is Greg Wilson. Could the gentleman from Los Alamos put his hand up? Okay, so you're partly responsible for software carpentry existing. Back in the 80s and 90s, I was the tame programmer in the physics department at the University of Edinburgh when first-generation parallel machines were coming out. And I can tell you the moment when I realized that we needed something like this. My job, and I'm sure a lot of you have that job, was to take whatever code the scientist built up over years or decades and make it go a zillion times faster on a parallel machine. So new faculty comes into my office with his 50,000 odd lines of Fortran, please can you parallelize this for me? And I feel this enormous sense of relief because when I open the file, and yes it is one file, there are actually functions. It's not one block of Fortran, there are lots of functions down the bottom of the file. Sense of relief lasts an hour, which is how long it takes me to realize that the functions are all the bits of code he's no longer using. Okay. Houston, we have a problem. Sorry, Austin, we have a problem. So, years go by, I've complained about this enough, and finally John Reinders, who at the time was running the Advanced Computing Lab at Los Alamos, told me to put up or shut up. Come and show us that if you teach some of these basic skills, the things that are too boring to be publishable any longer, that they work too well to be computer science research, if we teach those to scientists, will it actually make a difference? Lab skills for scientific computing, all the boring stuff that actually works. Well, here we are 16 years after we taught our first class at Los Alamos, almost exactly 16 years to the day after that first class at Los Alamos started. We believe that what we teach saves researchers a day a week for the rest of their careers by taking away the pain. What do we teach? Well, we tell them we're going to teach the Unix shell, GitHub, Python, or R, we're iconoclastic here, and some SQL. What we're really trying to teach them is how you automate a repetitive task, how you track and share your work, how you modularize a program. We want them to understand how to write code that is modular, readable, and testable, and that in fact those are the same thing. And we don't teach them SQL because we expect them to use databases. We teach them because we're trying to show them the difference between structured and unstructured data. So this is bait and switch. If we tell them we're going to teach them concepts, they don't show up. If we tell them we're going to teach them tools whose names they've heard of, they get really excited and they show up, and then we can teach them the stuff they really need to know. Right? So borrowing a line from Terry Pratchett, if you build a man a fire, you'll keep him warm for the rest of it for a night. If you set a man on fire, you'll keep him warm for the rest of his life. Right? Since we rebooted in January 2012 with money from the Sloan Foundation, 220 workshops, 234 people have taught for us, and about 140 of those have actually gone through instructor training and been certified, 6,800 learners to date. So it's a drop in the bucket compared to what's needed, but I think it's a good start. That's the places we've run workshops. You'll notice a big cluster up at Michigan State University, a big cluster in the United Kingdom. We're starting to fill in, and these are just some of the people who teach for us. So, lesson number one, if you take one thing away from this workshop, I want you to take this away. You are odd. You are not normal. Okay? You enjoy, I see 2 thumbs up from a couple of people, right? Most scientists think of programming as a tax they have to pay in order to do their science. They are no more excited about programming than they are about statistics. At which point I see somebody go, I like statistics. Right? So there's a bivariate distribution and you are doubly odd. Look, if they wanted to go into computer science, they would have picked that as their major instead of chemistry or nuclear engineering or whatever. Right? So we are the tail end of a distribution. So if we go in and say, gosh, this stuff is really cool, let me talk to you about recursion, we've already lost them. That took me 7 or 8 years to figure out. Okay. And that is why so many of the grassroots efforts to teach people programming eventually wither and die. Most people don't want to program. They want to get the PVR to do what they wanted. Right? They don't want to learn about call stacks. They want to make that piece of lab machinery behave so that they can get some data, so they can get the paper, so they can go home and get some sleep. Okay? Lesson number 2, the curriculum is full. Right? Everybody will agree that we ought to teach more computing at the undergrad level, at the high school level, at the graduate level. We should start in kindergarten. Nobody can agree on what to take out to make room for it. And until you're willing to answer that question, you're not being honest about the discussion. If you want more computing in high schools, you have to tell me what we drop. Do they not learn a second language? Do they not learn how the legal system works? Do they not spend time in the gym? Do they not do something else? You've got a fixed budget of hours. So if you want more computing, you have to subtract something. You have to subtract something from teacher training. You have to move budget around. Right? Everybody can think of what the government ought to spend money on. It's when you have to make cuts that you find out who's serious. This one took me about 4 years to figure out. Okay. But all of this stuff's in the paper. Go read the paper. I wrote all this stuff down. There's a lot in there about our teaching methods. There's a lot in there about other minor things that we've learned. Let me tell you what else I've learned. We actually, as a species, know a great deal about how people learn and how to teach them. A lot more than I realized even 3 or 4 years ago. Like most people with a background in science or engineering, I tend to be unfairly dismissive of anything that smells like social science research. Right? I made the same jokes that I think a lot of you made about, a mathematician says reality approximates theory, a physicist says theory approximates reality, a sociologist says, do you want fries with that? Right? We've all heard those jokes. It turns out that doing research on education is really hard, but also really worthwhile, and there is a ton that we know. If you take one other thing away from this talk, go get that book and read it. It's called How Learning Works. The Learning Sciences group at Carnegie Mellon finally put it down in 300 pages. This is a beautiful example of secondary literature. Do you want to know whether multimedia instruction works better than the traditional written word? The answer is, it depends. And they've got several pages telling you what it depends on and citations back to the primary literature if you want to follow them. Do you want to know what stereotype threat is and what the current balance is as to whether or not it's a real thing? There's a good summary in another few pages and references back to the primary literature. Do you want to know if flipped classrooms work? The answer is yes. There's references back to the study and the summary. If you are teaching or being taught, if you have kids and you want to be able to fact check the latest fad rolling through your school board, that 300 pages is a really good investment. And I really, really wish that it had existed 10 years ago and that I'd had the humility to read it. Let me give you a few highlights. And again, these slides will all be online. John Hattie in New Zealand has been doing meta-studies, amalgamating data from quite literally tens of thousands of studies of education over several decades. We're looking at effect sizes. That's basically percentage of a standard deviation. Okay. And as a rough rule of thumb, each grade in the public school system in North America is roughly a standard deviation up from the one before. Okay. Very rough guide. Lots of holes in what I just said. But think of this as fraction of a school year. Right? And I can already hear John going, no, that's not how it works, but rough guide. So shifting schools costs you about a third of a school year. Everything else being constant. Taking a kid out of the class they've been in and moving them to a different school, new teachers, new classmates, there's a penalty for that. And we know how big the penalty is roughly. Right? Web-based learning, the effect is so small it's not worth the investment. Those of you in school districts that are rushing off to buy iPads, tell them to stop. Right? It won't have any effect on how much the kids learn, and we know that. Teacher subject matter knowledge, that's interesting. Not a great big effect. It turns out that at the K-12 level, you don't have to be an expert in the subject. You have to be an expert in teaching. Right? Okay. That seems reasonable. What about class size? Well, here's a statistic that's already been misused. It turns out that large classes aren't the problem. Take a look down there at the very last item on the list. If there are disruptive students, that's the problem. And the larger the class, the more likely you are to have students who are disruptive or can't be controlled. But note, disruptive doesn't just mean bullying in the back of the classroom. I considered myself a disruptive student, right? I wanted the teacher to answer my questions, right? I wanted to pull things off track. So we're not talking about necessarily a bad thing, but it does cost the other students. Okay, there's a lot of really interesting information here. These are just the highlights out of a set of 6 slides in a larger deck. Are some of these numbers wrong? Absolutely. Absolutely. But I'm willing to bet that some of the science you're doing right now is wrong. That's the whole point. This is our best information to date. We should base our policies on this and then go and get better information. And we know this stuff. We just don't translate it into practice. Now look at the number for peer tutoring. Getting kids to teach each other will buy them half a year. Best way to learn something is to teach it, and we can quantify that. I wish I had known this stuff existed. Here's lesson number 4. Most people would rather fail than change. Right? They'd rather ignore what we know than change their working practices or their business plan. Right? Kind of sounds familiar to anybody working in climate change, doesn't it? Right? We know all of this stuff, and yet we don't reshape our teaching practices around it. Lorena Barba gave what I gather was a very good talk yesterday, 2 days ago. 2 days ago. Right? Flipped classroom works better. We can prove that. Very few schools in English language school systems are using flipped classrooms, despite the fact that we know it's a better technique. Because institutional change is hard, it's risky. And most people would rather keep doing what they're doing than take a risk. Hands up if you know that in the United States, MDs are actually statistically more likely than the average person to smoke. Right there, you know everything you ever needed to know about human nature. Okay? Here's some examples. Sub-goal labeling. Breaking down the problem and explicitly telling people what are the steps improves performance. And there's a link to a blog post by Mark Guzdial where he summarizes some of the research. Okay? Practice works best for facts. Examples work best for skills. Going through an example, showing people the steps, is the best way to teach them the skill. Okay? Peer instruction beats lecture. I hammer on this one many times. Media first increases retention. Just show of hands, how many people know Mark Guzdial, Georgia Tech? Read his blog. Hands down the best research group doing computing education research on the planet today. For years at Georgia Tech, they ran several intro programming classes in parallel. And one of the things they found, which has since been replicated at UCSD in the United Kingdom and down in Australia, is that if you introduce programming by having people manipulate images, they will remember more and they are more likely to stay with the course. Because it's an authentic task. If the very first thing you do in Python is load image, resize to create thumbnail, save, oh, I can see why I would actually want to do that. It's a lot more meaningful than sorting a list of strings or printing out the squares of the numbers from 1 to 10. And it doesn't sound like a big thing, but it makes almost a full standard deviation difference in how many people stay with computing. And we've known that for a decade. And it's a reproducible result. Yay, science. How many of you teach image manipulation as your first example in Python? How many of you were aware that we've known this for a decade? Okay. I wish I had been. Okay. Here's something else. Back when I was trying and failing to be an academic, my field of study was empirical studies in software engineering. Let's go and look at how people program. Let's collect some data and analyze it. And one of the things I did on my way out was help edit a book called Making Software. It's not as much fun as How Learning Works. I think it's still pretty good. And it's a collection of chapter-length essays from people who are doing real studies of real programmers. As far as possible, when we teach software carpentry, we try to base what we teach on the best available evidence. How many people here do test-driven development? You write the tests first and then you do the coding. On balance, the evidence shows that it doesn't make a difference to either the quality of the code or the speed with which it's produced, which strikes me as odd because I'm an enthusiastic proponent of TDD. So I'm in the awkward position of saying, I think of myself as a scientist, I teach scientists, the evidence says this doesn't make a difference, but I really believe in it. Okay, that's interesting, right? Either there's something I don't understand, or there's something the studies aren't capturing, or they've been badly done, or something, but that's how science makes progress. How many of you do pair programming regularly? Pair programming does make a difference But it seems that the effect, the benefit, wears off after a few weeks of working with the same person. Would anybody like to guess why? Get into each other's habits. How many of you are in a long-term relationship with a human being? Have to keep the crowd in mind. Okay. I knew I was going to marry the woman I'm now married to when we were on the phone, and she said, I'll meet you at that place near that thing where you took me that time. And I said, okay. Right? After a while, you start to think like the other person, so the benefit of the extra pair of eyeballs goes away. You want pair programming to be effective, you have to keep shuffling people. People don't like moving desks every few weeks. Okay? So again, we've got some interesting research. We don't base our practices on it nearly as much as we should. Let me give you another example, and this is my current favorite example. How many of you are familiar with Stefik and Siebert's paper? Okay. Don't read this. 2 surveys. What words and symbols might be easy for novices to understand? Let's go and do usability testing on programming languages. We know how to do this. Let's go and find out what novices trip over. So, if you give novices 12 words that might mean do this many times, guess which 3 they say are least likely to mean repeat. For, while, and for each are the least likely to mean repeat this. For means do it for somebody. While means, while I'm doing something else. Okay, so for accidental historical reasons, most of our programming languages use words that don't trigger properly with novices. If you were designing the user interface for a video game, you would do this test, realize nobody knows how to pick up the sword, let's fix the interface. Nobody knows how to change gears on the car, let's fix the interface. We don't do that with our programming languages, do we? Let's keep going. Then we're going to study the accuracy rates of novices using Ruby, Java, Perl, Python, Quorum, which is the language they're designing, and Randomo, a language with a randomly designed syntax. Perl and Java do no better than a language with a randomly designed syntax. And when we posted that result on the Never Worked in Theory blog 2 years ago, Andreas and his grad students started getting hate mail. People had gone to the trouble of looking up the email addresses of his graduate students to attack them personally. Okay? Does this sound like the reaction we get when we say, hey, anthropogenic climate change is a problem? So here we have a bunch of people who would think of themselves as scientists reacting in exactly the same way as the yahoos that I think many of us complain about who happen to be in government in my country. Right? Now, is this result right? Well, this is their second paper because they got burned so badly on that first one with that hate mail. They went back and they did these studies really carefully. I strongly urge you to grab the paper, look at their methodology, pick holes in it, and figure out how you do better. Right? But the fact is, I believe very, very strongly that all of the effort that went into Python 3 was misdirected. I have never, not once in all of the teaching I've ever done, had somebody come to me and say, I adopted Python because of the changes in Python 3. I wouldn't have used 2, I would use 3. But I have seen literally hundreds of people stumble and fall because they can't find stuff in the goddamn standard library. You explain OS versus os.path versus shutil versus the subprocess library, which still, sorry. Okay, I'm better now, right? If we had put the same effort into fixing that we've put into Python 3, we would be a lot further ahead today, and so would our users. But I don't have any evidence on which to base that claim. It is a strong personal belief, but we are supposed to be scientists. I think that every time somebody proposes a change to the Python language or the standard libraries, they should have to go and do a usability test and share their results with us before it gets incorporated. I don't think it would slow us down. I think it would speed us up in the same way that forcing people who are making medicine to go off and do the studies speeds us up. Right? We're supposed to be scientists. So, how's software carpentry doing? I told you we save researchers a day a week for the rest of their careers, and nobody put up their hand to say citation, please. Please now put up your hand. Do you know what a Scottish verdict is? A few hands go up. Courts in Scotland are unique in the English-speaking world in that a jury can return one of 3 verdicts: innocent, guilty, or not proven. And again, I feel very strongly that as scientists, our job is to deliver a Scottish verdict more often than most people. We are the ones who are supposed to say, I don't know, because I don't yet have enough evidence. I have some plausible theories, but I don't know which one is true yet because I don't yet have the data, I haven't done the experiment, I haven't done the analysis. So when I say we save researchers a day a week for the rest of careers, that's based on a lot of anecdotes, but it's subject to tremendous sampling bias. The people who don't get something out of a software carpentry workshop don't answer the email following up, by and large. The people who aren't getting a lot out of programming don't come to SciPy, right? And even if they were all answering, the question itself is probably meaningless. And at this point, I have to admit once again that, go back not very many years, I was fairly dismissive of social science research and qualitative methods, and unfairly so. I wish I'd been paying more attention, and I wish I'd been a little humbler. We do not know how to measure the productivity of a programmer, not in any meaningful way. We do not know how to measure the productivity of a scientist. You put those two things together, the unknowns do not cancel out. Right? Over and over again, funding agencies want to know, what sort of difference are you making? Well, we're doing surveys and interviews. Jory Shawsow at Michigan State's been doing a great job for us. But the whole point is we don't just make you do the old thing faster, we change what you do. We change the kinds of problems you can tackle. We open up new areas, new avenues of investigation. You can't, it's not even apples and oranges, it's goldfish and oranges. That's our goal, right? We need answers for funders. We need to be able to go back and say, here's the difference we're making. When we talk about investments in making more sustainable software, they need to know, is this worth our money? Because they've got a fixed budget and everybody else has a good story too. Right? We also needed to tune our teaching. And this for me is the more pressing need. I'm sure that half of what we teach in the average boot camp is useless. I just don't know which half. And I'm not even really sure how to tackle that question. Yes, it's going to vary for people in different disciplines, with different backgrounds, different situations, different career stages. But I'm not even really sure how to start getting a meaningful answer for this. If anybody here would like to be rich, famous, and popular, here's a problem to solve. Because the NSF would like to know too. Every funding agency would like to know this as well. Now, speaking of changing what people do, cloud computing isn't the revolution, neither is open access. They're enablers, right? The real change is massive collaboration, and this is something that I've only really woken up to in the last couple of years. The thing that we do now that is different is hundreds or thousands or tens of thousands of people will work together on a project without central control. And if you are 51, you remember when that was just weird. Like the idea that that could happen was just weird. And if you are under 30, you take it as normal. How many of you have ever edited a Wikipedia page? Do you have any idea just how science fiction-y that still seems to me? I'm serious, right? Nobody saw that coming. Go back and read science fiction from the 50s, the 60s, the 70s. Nobody saw Wikipedia coming. It's not there. The idea of open source software, in the late 1980s when I was at Edinburgh, I was doing some contract work for a supercomputer company called Mako, who was building first generation transputer machines. And I see a few people go, yeah, I remember. I remember having the argument with their director saying, we could just use this stuff that this bunch of wild-eyed crazies in Boston called the Free Software Foundation have been putting out. It's called GNU. And he was like, no, come on, they're going to be gone next year. It's not going to work. This open source, this free software thing, why would people just give away software? It's not going to work. Right? I spent 10 years in that fight. And now we pretend that we always knew what the answer was going to be. It was not clear that this was going to work. The idea of massive collaboration is the true revolution. Open access is just one of the things we need in order to do that. But there's something else we need as well. It's incremental review. You need to be able to look at the changes, not the whole thing. Last summer, and then again through the winter and spring of this year, we've been running a study of how to get scientists to adopt and use code review. And one of the very first findings is that doing code review at the end of the work, when the paper is being submitted, isn't useful. It's too big a chunk to bite off, and it's too late to make a difference. What you want, and this probably won't surprise you, is little bits of review as you're going along. I changed this, review that change in context. I changed this thing, review the patch, not the whole program. Doesn't seem weird to anybody? Does this seem weird to anybody? Right, seems pretty obvious now. You can't do incremental review unless you've got diff and merge. You've got to have a way to say what's different between what you've got and what I've got, and now let me merge those changes in rather than typing them in again by hand. You also need a culture of patching. You need a group of people who believe in making small changes and contributions. So again, hands up if you've ever edited a Wikipedia page. Okay, now hands up if you've ever sent a patch to an open source project. Okay. Now hands up if you've ever sent a patch to somebody else's PowerPoint slides or their lessons and had it accepted. Okay, this is a higher density than I've ever seen. You guys are odd. Right? Why isn't this normal? This is now the question that keeps me awake at night, along with what the hell happened to Brazil in that last game. Okay. I don't understand, I truly, fundamentally do not understand why people who teach are not diffing and patching and merging in the same way that people are doing on Wikipedia, in the same way that people are doing in open source code. Right? Every single one of the reasons I've come up with would also rule out Wikipedia, open source, or textbooks. Right? People don't see what the advantage to them is. Open source software shouldn't exist. Editing stuff collaboratively is too hard. Wikipedia shouldn't exist. People insist on only teaching from their own material. Lots of teachers use textbooks and start with those slide decks, like over and over again. I could understand if it was not yet the common thing. But except for a couple of point examples, it doesn't exist at all. And I don't understand why not. If you want to change the world, getting teachers and learners to collaboratively construct lesson materials and improve them the way that they have improved Wikipedia and open source software, that will be a bigger change than anything we have seen so far. Right now, out there in July, there are thousands of people preparing slides on how to differentiate polynomials, which makes as much sense as having thousands of people writing Django plugins to handle PayPal transactions. It's just as wrong, just as wasteful, and just as unnecessary. If you know why this isn't already normal, please come and talk to me. I'm not asking for examples of people who are actually doing it. I have found a few. I'm not asking for ways it could be done. I want to know why it hasn't already happened. Teachers are as cohesive a bunch as you can find. They know each other. They share lots of things already. They're intimately familiar with tools like Wikipedia. All right? We're making some progress on this. All of the lessons for software carpentry live in a GitHub repository. There's a mixture of IPython notebooks, Markdown files, and other stuff involving R that I don't understand and try not to touch. Right? But this is the reaction from one of our lead instructors who's been working really hard on these lesson materials with us. People are still more willing to submit new material than patch existing material. People would rather spend a couple of days writing a whole new lesson than a couple of hours improving an existing lesson. You've all worked with programmers like that. Many of us have been that programmer. My father used to say that a week of hard work could sometimes save you an hour of thought. Right? And we've all met that programmer who would rather spend a week noodling around building their own thing than pick up the library, read the documentation, and just solve the problem. But I think in open source we've largely got past that, and in science we've definitely got past that. How many of you have your own Large Hadron Collider? Anybody here own an orbiting space telescope? Perry puts up his hand. Yep. Got the second one on the way, right? Science builds on top of other people's work. Scientists don't seem to be willing to build on top of other people's lessons. We could really accelerate our training if we started to do this. And the problems are definitely not technical, right? But some of the problems are technical. Is Brian here? Brian Granger? And Fernando Perez? I love you guys. You've changed my world. I'm about to dump on you. Sorry. Okay, let me tell you how a typical software carpentry workshop goes. You shouldn't use Word. It doesn't play nicely with version control. The only thing you can do is mail files back and forth. Word evil. Okay? That afternoon, this is the IPython notebook. Isn't this cool? This is your electronic lab notebook. Look at all the things you can do. You know what's coming. Have you ever tried to diff an IPython notebook that contained embedded images? You must be this tall to go on the ride. Okay? We lose people there, right? Because we've just pulled the rug out from underneath their feet. We tell them version control is what you're supposed to use. And then we say there's all these file formats that you want to use that version control won't play with. And they are smart people. They are also scientists. They are smart enough to know that the only reason it doesn't work is because we can't be arsed to do it. There is no reason, absolutely no reason, why diff and merge should not have worked with Microsoft Word documents 20 years ago. I could pick 3 random people in this room, and in 6 months we would have a workable diff and merge for the basic features of Word. Right? If I got to pick the particular 3 people and the strength of the coffee, we'd probably be done by next Thursday, and yet it doesn't exist. So if you want to work with other people, if you want to work with the senior professor, with the granting agency, with the admin who's drawing up the budget, we're telling you, you've got a choice. You can either get them to learn LaTeX, good luck with that, or just look down your nose at them and say, you're not very smart, right? We're being arrogant. We're saying our way is the only way. And then we wonder why more people don't come and play. Now, we have started fixing this. How many people have had a look at NBDiff? This was an undergrad project in Montreal this last winter. Tavish Armstrong and his crew built a tool that will allow you to show the differences and merge the differences between 2 IPython notebooks. This is an open source project. I want 100 other things like this. If you want to get more people doing open science, build a diff and merge tool for Excel that will plug into GitHub. Okay, first thing you'll have to do is get GitHub to allow plugins, right? We've tried. They don't seem interested, right? We are the long tail. They are never going to build the things that we need because there aren't 20 million of us. But if they provided a plugin mechanism, we could build the diff and merge for the HDF5 files, right? For the FASTA files, for all of these other weird formats that we care about, so that people could migrate to our way of working instead of having to jump over. We don't currently provide an incremental path for somebody who's using Excel and Word on a Windows machine to come to us. They have to drop everything, leave their existing community behind, and emigrate. That's hard, and it's rude. So if you take a third thing away from this talk, building me a bunch of diff and merge tools for different file formats that will play nicely with version control will do a bucket load more for reproducible research in science than most of the efforts going on, because it will bring us more people step by step. Okay? Mike Hoy is the Firefox Engineering Community Manager. Here's his reaction to the current state of Python. You can't say he doesn't have technical chops. Right? He's trying to write a little bit of Python to manipulate some LDAP data. Right? Python is the new Linux is not meant to be a compliment. Okay? We need to make this easier for people. We need to think about the first 10 yards because that's where we lose 90% of scientists. It's not because they can't see what's out there, it's because they've got deadlines next Thursday, and doing things the wrong old way is guaranteed to get them their paper by that deadline. Switching and doing things our way, Maybe it'll be faster, but it could fail entirely. And most people would rather be risk averse. Over and over again, I feel like we went to IKEA and we bought this wonderful future and brought it home, but it's still in the box. And we're asking people who can't read the diagram and don't have the Allen key to assemble the future. Here's your future, right? All you have to do is put it together, right? So here's what you can do. Number one, make things work with version control. First order approximation, that will solve many of our problems. If the files that people have just plain work. Number two, or 1.1 rather, please do better than Git. Git is one of the most user-hostile systems I've ever had to teach. I can reliably teach people the basics of Subversion in under 90 minutes and they will actually adopt it. Give me 3 hours, and less than a quarter of the people I teach will actually feel comfortable enough with Git to use it. It has so many failure modes. It has so many contradictory pieces of syntax, right? It's like they did usability engineering and then flipped the sign, okay? Number two, patch our lessons or anybody else's, right? Lorena Barba's material is up there in a version control repository. You could send her patches. You could send us patches. I want us to start practicing the thing that we do that's new, this massive collaboration, with teaching materials so we can figure out what's not working now so we can do it better with the rest of the planet. Right? I need you all to have experience of diffing and merging and pull requesting lessons so we know what we should have built. Become an instructor for software carpentry. Come and help us teach. We will teach you how to teach. Hands up those of you who work in a university. Okay, keep your hand in the air if you ever taught how to teach. Okay, we can help you with that. Doesn't take very long. It's only a little, but it'll make a difference. Help us change the world. And this is why. This is my daughter. Everybody can go, ooh, right now. Thank you. Statistically, she is the cutest child on the planet, plus or minus 5%, 19 times out of 20. You don't want to be around on day 20. She is inheriting a world that is faced with huge challenges. Climate change, mass extinction, resource depletion, drug-resistant diseases. The only things that are going to get us through the next 50 years are more science and more courage. I need your help with both. I think we're doing the right thing. Thank you very much.